Hello students, I am Chavi Sahai, Assistant Professor at AI SSMS College of Hotel Management and Catering Technology. Today for this session of Bridge course, we shall start with the new chapter, that is Properties of Matter. Under this, we will be covering the topic on change of state and calorimeter. Let's understand the objectives of this video session. The first one would be to learn about what constitutes matter. Second one, to learn about the classification of matter. Then to learn about properties of physical state of matter, namely solid, liquid and gaseous state. To learn about various change of state, to learn about calorimeter, to learn about various types of calorimeter in brief, and lastly to learn about the uses of calorimeter. Now let's understand first what is matter. Matter is defined as anything that takes up space and it can be weighed. In other words, matter has volume and it also has mass. There are many different types of matter in the universe. We will first see how do we classify matter. Classification of matter is done according to their different chemical and physical properties. Let's first understand what are physical properties. The physical characteristics include size, color, shape, temperature, boiling point, melting points, density and mass. These properties define the physical nature of matter. On the other hand, the chemical characteristics define the chemical elements that are present in the matter. For example, if we say, we all know water boils at 100 degrees Celsius and it freezes at 0 degrees Celsius. This defines the physical properties of water. The chemical properties of water will include pH levels that are present in it and the amount of oxygen dissolved in water. Now we come to the broad classification of matter based on the chemical state. First, it includes pure substances and impure substances. Now let's see what do we mean when we say pure substances. These substances are made of similar atoms or molecules in a specific defined ratio. Therefore, they have a homogeneous chemical composition. This classification of matter, that is, the pure substances, can be further classified into two types. First will be elements. Let's begin with elements. Elements are defined as pure substances that contain a single type of atom or a molecule. They can't be broken down further by any physical or chemical means. In the same type of pure substance, the next one is a compound. A compound is formed when more than one element combines chemically in a fixed ratio. Pure compounds can be changed into newer substances by way of a chemical process. Some examples of these substances are common salt, NaCl, carbon dioxide, CO2, and water, H2O, and there are many other. Next, we come to impure substances. Impure substances are made of different types of atoms or molecules. Unlike pure substances, Their structure is not fixed or constant. This classification of matter can be further subdivided into two categories based on their composition. First one being a homogeneous mixture. A homogeneous mixture have the same composition throughout their volume. The amount of substances present in every sample of homogeneous mixture is always the same. Example of a homogeneous mixture would be oil, salt solution in water, and others. Next is a heterogeneous mixture. A heterogeneous mixture, on the other hand, has a varied composition throughout its volume. Unlike the homogeneous mixture, these mixtures don't blend perfectly. Some examples of heterogeneous mixture would include mud water, concrete, and also chocolate chip cookies, etc. Now let us see the classification of matter based on the physical state. It is classified into three, first being the solid state. The solid state of matter has a definite shape and volume due to its closely packed particles. They may break if you press a solid, but their shape cannot be altered or changed. That is why solids are most inflexible of all forms of matter. Some examples are rocks, ice, wood, etc. Next, we come to the liquid state. Liquid particles have more space among them than solid particles. That is why these particles are capable of free movement. Liquids, unlike solids, don't have a definite shape, but they do not have a definite volume. They can alter their shape and take the volume of the container in which they are kept. Examples are water, oil, petrol, etc. Next is the gaseous state. This phase of the matter doesn't have any fixed shape or volume. The gas molecules have a huge amount of space between them. They are capable of free movement and can move around at random. Examples would include carbon dioxide, air, etc. Now, when we talk about the change of state, we are talking about change of one physical state to the other. For example, if we say change of solid to liquid and vice versa. We can understand first with an easy example of water. When water, which is in its liquid state, is heated, it changes to gaseous state. Similarly, when steam, the gaseous state of water, is cooled, it becomes water, the liquid state. So some of the changes of state include the following: melting, change of solid to liquid; vaporization, change of liquid to gas; sublimation, change of solid to gaseous state; condensation, change of gas to liquid; and freezing, change of liquid to solid. Now we will discuss about each of them in a little detail. The first one being the change of phase from solid to liquid. As a solid is heated, its particles vibrate more rapidly. Eventually, the solid starts to melt. The melting point is the temperature at which a solid changes into a liquid. Let's understand it with the same example. If we take some ice cubes and we heat them. What we will see after a while is that the ice cubes are dissolving in its own liquid. As we keep heating, the ice cubes gradually become smaller and turn into water. This change of state is referred to as melting, and it is a change of state from solid to liquid. The temperature at which melting takes place is called as the melting point. Now we will talk about evaporation. Evaporation signifies the change of state from liquid state to the gaseous state. Vaporization or evaporation is described as the process by which an element or a compound changes its state from liquid to gaseous state. Simple heating of water, and when it evaporates becomes steam, is an example. Boiling is the process by which this happens. When a liquid is changing phase to the gaseous state, it happens because of application of heat. Now we will move on to the third type of change of phase from solid to gas, which is called as sublimation. We can define sublimation as transition of a substance from the solid phase to the gaseous phase without changing into liquid phase. Example would include the naphthalene balls. They sublimate and change into the gaseous state. Next we come to condensation. Condensation is the process where water vapor becomes liquid. That is change of state from gaseous state to liquid state. It is the exact reversal of evaporation, where the liquid becomes a vapor. Next is freezing. The freezing refers to the phase change of a substance from a liquid state to a solid state. This is the phase change where the substance is transformed from liquid state to a solid state, like water to ice. Now we move on to the next part of this session, where we will discuss the topic of calorimeter. Calorimeter, as the name itself suggests, that it is an instrument, but it has got nothing to do with measuring the calories of food that we consume or any calories that you burn at the gym. So what are we talking about? Calorimeter is a device that is used for measurement of heat. It mainly consists of a metallic vessel made of materials which are good conductors of electricity, such as copper and aluminium. Along with that, there is also a facility for stirring the contents of the vessel. A calorimeter is a device which is used to measure the amount of heat involved in a chemical or a physical process. A calorimeter can be used to determine the specific heat of a substance, also to determine the heat given off or absorbed by a chemical reaction. You can see the diagram of a calorimeter. It has many parts, namely a thermometer, a stirrer, an insulated container. It will have some airspace and also an ignition coil. First, let us understand what are two types of reaction where we use the calorimeter. First one is an endothermic reaction and the other one is the exothermic reaction. Let's just briefly understand what are these. Endothermic reaction, when we say, what we mean by it is, endo means absorption and thermic relates to heat. So a reaction that absorbs heat. In this reaction, where the system is absorbing the energy from its surrounding in the form of heat. A few examples of endothermic process are photosynthesis that happens in plants, evaporating liquids, and also melting of ice. Heat is taken up from the surrounding in such reactions so that the temperature of the system where the reaction is taking place remains cooler. Next, we come to the exothermic reactions. When we say exothermic, what we mean is, exo means to release, and thermic again refers to heat. The exothermic reaction is the exact opposite of an endothermic reaction. It releases energy by light or heat to the surrounding. Some examples of exothermic reaction are burning of a substance, reaction of fuels, and also respiration. A calorimeter is a device used to measure the amount of heat involved in a chemical or a physical process. For example, when an exothermic reaction occurs in a solution, inside a calorimeter, the heat produced by the reaction is absorbed by the solution, which increases its temperature. The temperature change can be used to calculate the amount of heat involved in either of the cases. Now coming to the types of calorimeter, there are 5 types. First is the adiabatic calorimeter, reaction calorimeter, bomb calorimeter, constant pressure calorimeter, and differential scanning calorimeter. First, the adiabatic calorimeter is the one in which the heat produced in the reaction is not allowed to escape from the calorimeter to its surrounding. It has an adiabatic shield which traps the heat inside. Next is a reaction calorimeter. It is a tool used by scientists in the field of medicine development to measure the amount of energy that is released or absorbed by a chemical or a physical reaction. It typically consists of a stirred tank, reactor of variable sizes, in which the temperature of the reaction is monitored and controlled. Next, we move on to the bomb calorimeters. The bomb calorimeter is used in the laboratories to measure the amount of heat produced in any sample. This is typically used by the science students. The top of the bomb carries an oxygen supply connection and a valve to release the heat. The bomb is placed inside a copper vessel which contains water. There is a stirring device to stir the water within the calorimeter. The temperature of the water in the calorimeter is measured by a thermometer. Now let's see the constant pressure calorimeter. In this type of calorimeter, it is made of 2 styrofoam cups, a stirrer and a thermometer. Hence it is also called as a coffee cup calorimeter. We place 2 styrofoam cups inside each other. The reaction happens in the inner cup and the change in the temperature is recorded. It is named as the constant pressure calorimeter because the system is open to the atmosphere and thus records the temperature change at constant pressure. The last type of calorimeter is the differential scanning calorimeter. It is a thermal analysis instrument. It measures how physical properties of a sample change along with temperature in a particular period of time. Now we come to the end of the session. Just to conclude, in this session we have covered about what constitutes matter, how do we classify matter, the properties of physical state of matter, what are the various change of state, what is calorimeter, various types of calorimeter and its uses. Thank you.